Okay, so now let's get started with Singleton Design Pattern. Okay, so Singleton Design Pattern means you just want only one single object to be created per container. Okay, so you don't want multiple objects for a class. You just want only one single object. And when this is normally used, so when the particular class object creation is quite resource intensive, so then you will actually go for single object. Okay, and you have some instances where that is already used, so runtime.getRuntime or security manager in the class system, so they are all singleton objects. Okay, so let me confirm this. Okay, so you will not be writing any singleton code normally. Okay, so when you go to server side development, so let's say when you are developing some components in Spring, okay, say account service, something like that. So when you are designing these classes, you will be annotating that with that service annotation. Okay, so Spring actually uses the singleton. So it only creates one single instance of account service, and the same instance will be serving all the calls or all the dependency references. Okay. So this is something that is framework will be using it, okay, very extensively. But as far as you are concerned, your understanding is important again. Okay, and this is regularly asked in interviews. Okay, so people will be asking about how do you code for singleton. Okay, so that's the reason why this is extremely important for you to understand. Okay, not just for interviews, guys. So for the framework, so where you are going to see the Spring components which are coming in future when you start server side development. Okay, they are all singleton by default, so you have to make some configuration changes in order to be not uh, using singleton. Okay, so for now, okay, so let's just theory apart, let us start with the code. Okay, and see how you can code for a singleton. So let's start with a class called sample again. Now, when I create a class sample, so I can create any number of objects of sample. Okay, so do you agree with me? So that's the point. You don't want multiple objects to be created. So you don't want this to happen. So you want one single instance of sample. Okay. Now, if I allow object creation, certainly they are going to create. Here, they means the clients. Okay. Somebody who is using sample. Now, this code, main is the actual client code in this case. Okay. Now they can create any number of objects. So I can have any number of objects of class sample. So how should I restrict? So if I allow object creation from an outside source, that means I don't have any control over how many objects are getting created. Okay, so let's actually put that inside the definition. So what I will normally do, I will create a constructor and I'll make it private. Now I restricted object creation from outside. You can clearly see that. Okay, now you cannot create an object from outside. Okay, so that's fine. Now how do I create an object? Okay, so if nobody can create an object, so let's say there is some function called say hello. Okay, with the string name, and this is going to print hello and name. Okay, now if I need to call this function, this is a non-static function. So non-static means I need an object. So now this method requires an object. So how am I going to call this method without an object? Okay, so that is something that we have to handle this. So outsider cannot create an object. So what I will do, I will actually write a static method. Okay, so say sample, and I will make it getInstance. So I'll name it getInstance. Okay, so this is a static method. You can also call it as factory method. Okay, now this is going to create an object. So let's say return new sample. This is good. Now what should they do? So instead of creating object directly, so that is new sample, they should actually go with the sample dot get instance. Okay, again, so sample dot get instance. Now if they call the get instance method for the first time, okay, so they call the get instance method for the first time and they got one object, and they call the get instance method second time and they get another object. So which is not what we want to do, right? So you don't want multiple objects to be created for this class. So how do I go about it? Okay. So I want only one single copy of instance. So what will I do here? I will actually create something called as static sample some instance equal to new sample. Okay. So this is going to be a private member. Now I created a single instance. Okay. So this is static. So what do you mean by static? So it's a class level copy. So how many objects of instance, how many fields of types instance will come for a sample? So there is only one instance, because being a static member, you will only get one single copy of this variable. Okay. So that means there will be only one particular variable called instance for the entire class sample, because it's a static member. Now, that variable holds the reference to the object that we created. Now, every time whenever somebody is calling getInstance, you simply return this instance. Okay, that's it. Now you get both the objects are getting the same instance. So how can I prove that? So I can simply say is s1 equal to s2. Okay, let me show that. So I can say s1 is equal to s2. So equal to operator will perform the reference comparison. Now it actually compares the references inside s1 and s2. So s1 is a pointer to an object. Okay, so it's you're going to hold some value which is the address of this object, and similarly s2 holds a reference to this object. Okay, now s1 equal to s2 is equal to true means both are referring to the same object. So that's what it means. Okay, now is it going to return me true? Yes, it is. So because both the calls to get instance is returning a one single instance, that is this one. Okay, so is s1 equal to s2 is true because both are referring to the same object. Okay, so what is that you did? So what you didn't allow, so sample s equal to new sample is not allowed. Okay, because constructor is a private field. So because the constructor is private, object creation is not allowed. So you don't have any other constructor to choose as well. So you have only one choice, that is this constructor, that is no argument constructor. And because it's private, so you cannot create an object directly. Now, how can I create an object? So how can I make use of the methods or the members of that class? Okay, now for that reason, because we restricted object creation from outside, we are supplying a factory method. Okay, we are creating a method called getInstance, which actually returns the object. Okay, so which returns the instance, and this object, each call to getInstance will return the same object again and again, and that is the static reference variable called instance. Okay, so what do you mean by a static variable? So static variable is a class level variable, and only one copy of the static variable is maintained in memory. Okay, so there will be only one copy of instance variable maintained in memory which holds the reference to the object, and every time when somebody calls get instance, you get the same object again and again. Okay, then you can make you can make all the other member calls, other stuff, okay, as you wish. So this is a very simple singleton for you. Okay, so I think we will certainly need to go slightly beyond if you want to do well in the interviews for this question. So for now, this is at a high level what is a simple singleton. Okay, now let us see the refinement of it and see how can we improvise it in the next lecture. See you in the next lecture. So you already know what is now singleton is. So this section is what we call as this way of initializing the object is what we call as an eager loading. Okay, so eager loading means no matter whether that is needed or not, you are creating an instance for sample. Okay, no matter whether it is really needed or not. So this is not something that we want. Now let us see how we can do a lazy loading. So lazy loading doesn't create an object early. Okay, so lazy loading, so this initially it will be set to null, so you don't need to really initialize it with null. By default that is null. Okay, now you want to create an object when it is absolutely needed, so when it is requested, so for the first time. So inside the get instance, okay, if instance is equal to null, so that means it is not initialized, so then you initialize it. Okay, new sample. Now this is a lazy loading for you. Okay, so here you are going to create or create the instance only when it is initially requested. Till that point you are not initializing the object. Okay, so this is lazy loading, and the rest of the code remains the same. I think this is good, but there is some problem associated with this kind of loading. Okay, so what is that problem? So before even going to getting into these things, okay, so we will see what are the other problems that we might come across. Now somebody who is using reflection will still be able to create an object for this class. Okay, so let me first show you that. So what I am going to do here, so I'm going to paste a small code snippet that I have already done so that I don't waste your time. Okay, okay, so this is your code. So how you can use the reflection. Okay, using reflection, this is going to throw exceptions, so let me throw some exception. Okay, good. So what I did here, so I have already gone through this code snippet when while explaining the reflection APIs, guys, so you just need to revisit that section if you are looking to understand this. Okay, so we loaded the class object, and then after we got the class object, so we tried to access the no argument constructor of that class. Okay, and there is a method called try set accessible, which actually tries to make this private as public at runtime. Okay, at runtime, so not for everywhere. So this is for just for this reference. Okay, so it's trying to set it to accessible, so once it is accessible you can create an object for this class. Okay, now let me show you it is a different object or the same object. So I'm going to copy this line and I will say is s1 is equal to that object. So is s1 is equal to that object. Okay, so here this is expected to be true. Okay, and what about this one? So if this is true, then it is same object. Okay, if it is false, what do you mean by that? So if this is false, that means that these two are two different objects. Okay, now let's see whether this returns true or false. You can clearly see that this is false because we created an object through constructor. Okay, so this is the first problem that you want to solve. So using reflection, if somebody is trying to create an object, because they did not come through the get instance, okay, they were able to create a different object. So how to control that? Okay, let us see that. So what I will do here, when somebody is coming through reflection, okay, how will I know that they are coming through reflection? So again, if I throw exception here, if I throw say new some illegal state exception, you cannot create object. Okay, so if I do this, I'm also going to throw the exception for this call. Okay, so this is also invalid, so I'm going to throw for both the cases. So this application itself is not going to work. Initially itself you got that problem, so you can clearly see while going from get instance. Okay, so the new sample is also rejected. So this is not what we want to do. So what we want to do is allow when this is first object. Okay, so if instance is equal to null, okay, then say that instance equal to this, so the current object, so you are setting that reference to the current object. Else you throw this exception. Okay, so for the first call, whoever is calling first, okay, so that this assignment will be valid, and from the second call onwards it throws illegal state exception. So this application again is going to fail. First call of get instance will look for whether the instance is null. If it is null, it creates an object, otherwise it returns. Okay, now these two lines will pass through because they will return the same object for both the calls. Okay, but this is going to fail now because when you try to create an instance, okay, so instance through reflection, instance is not null, it is already set to some object, so it comes and throws the exception. So let us see that. So you can see that the first calls are valid. So it went through this step, it went through this step. But when it comes to constructor.new instance, okay, so at this line, if you can clearly see line number 60, when it went through the constructor.new instance, okay, so it tries to make it accessible, make the constructor accessible, but inside the code, so if the instance is not null, so because its object is already created, so you simply throw this exception. Okay, so what is the point of this one? So if they are trying to use this code, okay, if they are trying to use this code before all the calls, okay, so if this is the first thing which is getting invoked, so now the instance is null. Okay, this is the first time you are making a call, so now the instance is null. So instance is this means you already created an object. Now you held the reference of this inside the instance, so that next time when the get instance is invoked, you simply say it is not equal to null, so return that same instance. Okay, so for this reason I have to actually use the first part of it. Okay, now let's see. No, so now you are not going to see any exceptions, guys. So even this will be successful. Okay, you will see an object because this is the first occurrence, and from next onwards get instance will return the same instance. So all three instances will be true. Okay, so if you are getting confused, maybe you might have to revisit this lecture again and again. Okay, so but I can't help, guys, so this is what it is. Okay, so then now you all three instances are same. Good. Okay, so there is again one more problem, and the problem is the this object can be serialized and later it can be deserialized. Okay, so let me show you how. So this is the small code snippet which explains you how you can serialize and deserialize. Here I am doing the serialization. Okay, so here I am doing the deserialization. Okay, so we have something called as byte array output stream, and through byte array output stream you can write anything, any data in the form of bytes. So this is kept inside memory, so it's actually buffered in memory, and then when you write the object, you know that how to do this one. So you can refer to object serialization and deserialization. Okay, object output stream is connected with byte array output stream. So when you give an object, okay, so this is going to convert or serialize that into bytes, and the bytes is written to the byte array output stream. Okay, and then once you close this stream, so you are done with object writing. Next, you take the byte array dot two byte array. So this is going to give you all the bytes. Okay, all the bytes which were dumped into the byte array output stream, and then using these bytes you can reverse that operation. So just like this, guys. So if it is file output stream, it might be written to file, right? So if it is byte array output stream, it is written to some byte array in memory. So you are not writing it to file, you are writing it to the byte array in memory, and then once done you collected all the bytes. Okay, so this is collect the bytes written. Okay, and once done you again reverse connect it. So you want to take these bytes, give it to byte array input stream, which constructs a stream out of bytes, and then you connected that with object input stream so that you can read the object. Okay, and now let us see if this is the same object which is returned. Okay, so what I can say now, so I'm going to say if object is equal to object 2. So this is object 2. Okay. So if object is equal to object 2, so is it equal or not? It's something that I want to see. Okay. So this is using object in dot close. You don't need that anymore. Okay, so now let's see what did we get. Okay, so if it is not equal, that means you created another object, right? During serialization and deserialization, you are able to create a different object, so which is not intended for singleton. So now let's run and see. Yes, it is not serializable exception. Okay, so your code didn't work, it's not the output. So the object is not serializable because this class doesn't implement the serializable interface. Okay, let's do that. Now if this class is implementing the serializable interface, it's just a marker interface which says that okay, so sample is serializable, that's all, nothing beyond that. Now sample is serializable. Now you can see if this serialization and deserialization works or not. Okay, now let's run and see. Now you can see the last step, object is equal to object 2 is false. That means both are different objects. So you created more than one object, and that's again a problem. So you want to fix this. Okay, so how can we fix this one? So to fix this problem, so to fix, okay, serialization issue. So what you need to do is you need to actually provide a method called readResolve. Okay, so which resolves the red value. So you just need to return the same instance. Okay, so return the same instance so that it doesn't create a new object. Okay, so this is something that you need to do. Now let's see if this read object is going to return the same thing or not. Okay, let's run and see. Okay, so finally you got it. So both the objects are same. So this is because you are able to fix this using readResolve. Okay, so you now have some issues resolved, guys. So you went for serializable and you fixed the readResolve, the deserialization specific issue. Then you went for a constructor reflection related issue. Okay, so you are able to now block almost everything. Okay, so what is still not fixed in this problem? So that is when multiple threads are trying to access the get instance. So I did not cover the multi-threading in as part of this course because it deserves a complete new course altogether. Okay, so you can find my dedicated multi-threading course, and you can find the link to that course in the last lecture of this particular course. Okay, the bonus lecture, or else you can visit my website and find where the course is. Okay, but anyway guys, so this is not a pure multi-threading course, it deserves a very dedicated course on top of it. So I just need to fix it. I will show the fix for this particular multi-threaded issue because that will complete the singleton pattern at least. Okay, so I'll show the fix, but I may not be able to explain each and everything in much more clarity, in much more detail. Okay, but anyway, this is at a high level how we fixed it. Now let's see how we can fix the multi-threaded issues, concurrency issues for this one, so that we can complete singleton. Okay. So now I'm going to apply the multi-threading specific fixes here, guys. So for singleton, okay. So let me show that. So you need to make this variable as volatile, okay. And there is a reason behind it. So volatile, actually these variables are not cached, so they will be, each and every write operation will directly go to the memory. Okay, and because if two threads are looking at this, if two concurrent threads are looking at it, So they may both see that it is null. So one might write it, and the other might also create a different object. So you don't want that to be cached. Okay, so that's how it is fixed. So that is volatile. Even if you did not get it completely, so don't worry. So this particular part is completely covered as part of multi-threading course normally. Okay, now if instance is equal to null, so I need to synchronize the operation. So here there is something called as synchronize the operation for multiple threads. So I need to be using synchronized, and I want to lock the class object. So let's say the class object. Okay, so what it does is, so this actually locks the class object before entering inside, so that only at any given point of time these statements are executed only by one single thread. Okay, it's in a simple terms, it's like this, guys. So there is a forward junction. Okay, and you have signals placed. So what is the role of signal there? Okay, so what's the traffic lights? Okay, whatever it is, so whatever the name that you give. So why did you place the traffic lights? So that is a shared resource. Forward junction is a shared resource. Okay, somebody who gets green, only they can pass through. Okay, so rest of the other four other three flows. Okay, they should wait till this the till they acquire that lock. Okay, so till they get the green signal. So something of that sort. So synchronized will actually lock one object. Only it gets inside, a thread gets inside if that is locked. Okay, now only one thread at any given point of time can create an object. Okay, but again, so you need to ensure that this is still null, because by the time thread reaches this point, object might be created. There is a other thread which might have looked at the same issue, and it might have created that object. So you just need to ensure that the instance is still null. So if instance is still null, okay, so if the object is still not created, only then you create the object. So this is what we normally call as double checking. Okay, so initially you checked it. If it is not null, so you simply you because synchronized is a slightly costly operation, so you don't want to do it for each and every call to get instance. Okay, and for that reason you initially checked for whether it is null. If it is null, yes, there is a possibility you need to create an object. So you went inside, you synchronized it. So if it is not null, you simply skip this if statement, simply return the instance. Okay, so this particular thing will help you to not to synchronize each and every call. Okay, that's a costly operation which you don't want to do. Okay, that is first point. And second, by the time you reach this point, you need to ensure that it is still null. Okay, only if it is null, then you create the instance, otherwise not. So this is your simple concurrency or thread safe code, guys. So I think that's what I can explain in this course, because there is quite a lot of other things which need to be explained. Okay, as far as multi-threading and concurrency is concerned. So where you can find a dedicated course altogether on this one. Okay, so I do have one. You can check it out. Okay, if you are looking for multi-threading. So it's also really important for interviews. Okay, not only for interviews, server-side programming, it's a must if you are looking to learn the server-side programming in Java. So that's it. So we almost fixed almost everything when it comes to Singleton. Okay, so first thing let's have a high-level recap of it. We have a static instance variable, so which is static, so only one copy of instance is maintained, and we are trying to populate that instance with an object when somebody is calling getInstance. Okay, so then we try to solve this issue of object construction, and still, guys, still this is not a perfect code. Okay, you might have to fix the issues here, you might have to fix the issues here. So there may be some other technical issues which I don't want to dig too deep into, because whatever the understanding that I have given you, I think that should be more than enough as far as Singleton is concerned. okay, as far as the interview process is concerned. And if you are using the frameworks, let them take care of all the singleton instance creations and other stuff. So you will not be doing any coding as this one, okay, almost in your, I don't know. So if you are not developing the frameworks, if you are developing the frameworks, maybe yes, but not at least in the other software development. Okay, you may not be writing it, but only for interviews this is important, and understanding is important. Okay, right. So you created a single variable, a static variable, and you made a get instance. It's a factory method which returns the object once it was created, and it always repeatedly return the same instance instead of creating new instance for each call. And then during the constructor, you may make sure that the instance is not there. If it is not there, then you created it. So this is only one time, you allowed it only once, okay, and from the second time onwards you started throwing exceptions. And during fixed the issue during deserialization process, somebody can serialize a singleton, and then they can do a deserialization of it, okay, to get a second instance, and you fixed it by simply returning that instance. Still there are issues, yes, honestly yes, because it's not a 100% perfect code, but this is what it is. I think you this is at a high level, guys. So this is how you write the code for singleton, okay. So if it is confusing, maybe you take time and come back to this again, okay. So for now, this is what it is. So both s1 and s2 are same. S1 and object are same, which was created during reflection, and then object and object 2 are same. So object 2 is the one which we tried to deserialize, okay. So we fixed almost all the issues, and if it is still confusing, come back to this lecture again after some time, okay. But there is no other choice. See you in the next lecture.